All right. Well, it's Sunday night. I got the Eagles on right now. It's just getting started, so if you hear some hooting and hollering in the background, it could be me watching the game or the rest of the family over there pulling for the Eagles. But good day today, right? Flyers won. Eagles are on now. Football start at 9 a.m. So busy day with sports, but I'm out. I got a soccer game myself right now. We are at the high school. We got a game at 2, so I had to leave early. So what I did, I put a little video together for you on 4.2. So 4.2, as you can see, is patterns and linear functions. All right, a lot of definitions in this section, and sort of understanding what functions are and then what linear functions are. Okay, is sort of is the main idea here. So some of the notes that I put down for you. Okay, what is a function? So a function is just a relationship that pairs an input with exactly one output. Okay, again, so you put something in, you get something out. That creates a function. A lot of times we're going to be able to graph these functions and see what they look like, but for right now we're just understanding if you put something in, so x is your input, I put in 1, I get an output of 9. I put in 2, I get an output of 5. I put in 3, I get an output of 4. That's basically, we can say that's a function right now. The relationship is a function. Whereas over here, this one would not be considered a function. Now remember the definition, for each input, you get exactly one output. So if I input 1, I get 0. But if I input 2, I get 5. But then if I put 2 in again, I get a different number. See how 2 gets 2 different outputs? That means this would not be considered a function, because when I input 2, I get 2 different numbers coming out, okay? And we're going to be able to visualize what functions are in a little bit. Okay, so x is considered the input, y is considered the output. X is also known as the independent variable. I'm going to show you an example in a second. And y is known as the dependent variable. Y depends on x. So we plug x in, and then we figure out what y is depending on x. So imagine this. Imagine you make $10 an hour. If you set up a little table, x is the input, x is the number of hours, y is the output, would be the total you make. If I work 1 hour, y would be 10. If I work 10 hours, 10 times 10 would be 100. If I work 20 hours, 20 times 10 would be 200. So the input here, or the x, that's my independent variable. I can pick whatever number I want and put over here, and then y would depend on that. I would multiply it by 10. So x is the input. X is also known as the independent variable. Y is the output. Y is the dependent variable. Okay, that's what that says right here. I'll put pictures of this online too if it's kind of moving around too much for you. So remember, if each input has exactly one output, you have a function. So what's a linear function then? That basically means you just have a line. Linear, L-I-N-E, line. When the graph makes a straight line, with one exception. It can't be a vertical line straight up and down. Any other straight line is considered a function, and I'll explain why, because basically that breaks our rule that we have for each input exactly one output when I show you. Okay? So just kind of finishing this up here. Functions or not. So if I were to look at this one, why would this one not be a function? Notice I have 5, I get 3, 6 gets 2, 5, I get 4. Can't input a number twice and get 2 different outputs. That's not a function. Is this a function? For each input, there's one output. So we didn't really talk about that. It's definitely not linear because it's not a straight line. But look what happens here. Let me grab a pencil. Give me a second. Or a pen. Okay, look what happens. Like if I input the number like right here, this number right there, I would get this as an output. I would get that as an output. I would even get this as an output. So let's say that was -1. At -1, I have 3 different outputs, which means not a function. Okay. We'll talk about what the vertical line test is later, but you can see if the line crosses over itself, no function. Okay, because that's telling you for that input you have more than one output. But anyway, so let's see, is this a linear function, y or y not? So if you have a table of values, okay, there's my input, output, input, output, input, output. So you can see it's definitely a function, but is it linear? Well, you can graph it to see if it creates a straight line, or you can check to see if the pattern remains consistent. If I see from 0 to 1, it's a change of 1. 1 to 2 is a change of 1. 2 to 3 is a change of 1. And then over here, 5 to 10 is 5. 10 to 15, 5, 15 to 20, 5. If that pattern remains consistent, 5 to 1, 5 to 1, 5 to 1, it is good. I can even have a number here like 5, and I have a change of 2 here. And if my output was 30, and that would mean I went up 10, that pattern still remains consistent. I went 5 to 2, 10 over 10 to 2 is still the same as 5 to 1. So yes, this would be considered linear. And again, I could graph it to see it would create a straight line. Is this one linear? Does it create a straight line? Nope. It's a function, but it's not linear. Okay? So it's just some definitions that you should know based on this is, what is a function, right? What's a linear function? Understand what is the input, what's the output, and what is the independent variable, and what is the dependent variable. These colors mean nothing here, guys. I was just separating them. So the output actually is the dependent variable. The input is the independent variable, okay? And a function, we know that for each input we get exactly one output, and linear function means we have a straight non-vertical line. Okay, so in the textbook, okay, on page 240, there's some reading you could do in here, all right? And you can see the lesson vocabulary, just what we went over. That's what you need to know, all right? And really what we do is you try to create patterns here if we're trying to find a linear equation. We're going to spend a lot of time practicing this, all right? So if you read through these examples that are on here, and they ask you to see if it's a linear equation, notice what they do here is they have a table of values. You have your input, you have your output. They check the pattern over here. Does it remain consistent, the pattern over here? Yes, so it's considered a linear equation. Now, if you're trying to write the equation, all right, I'm going to show you tomorrow a couple little tricks, but you're just trying to figure out what the pattern is. So if I input 0, how do I get 512? If I input 1, how do I get 509? If I input 2, how do I get 506? That's kind of tricky. It's not necessarily easy to see in all cases, but today I just want you to try. Tomorrow I'll give you a couple more tips on that, on what to do, okay? If you're given something like B here, does the set of ordered pairs right here and represent a linear equation? Explain. Well, you can graph them to see if they form a straight line. You can put them in a table of values like this and see if you have a constant or a consistent change from your inputs and your outputs, just like we did up here. Okay, and if that's the case, then the answer is yes. All right, so read through this the best you can. Try to do the problems that I will leave for you. If you get stuck, just try something. Go back, read through the textbook. I'll try to attach a couple of videos online for you for the Pearson Realize that you can view. And again, I'll put the pictures of the notes that I had on my e-board. All right? So nothing's really going on in the Eagles game right now. We're still 0-0. It looks like I missed part of the Eagles' first drive. Not sure what they're doing. So that's what I'm going to get back to now. I'll see block 1, 2 tomorrow morning, but I'm not going to see block 5, 6, all right? I'll have your test for you. I guarantee your chapter 3 test will get back to you on Tuesday, all right? All right, people. Good luck, and see you on Tuesday.